So let's look at a few examples from 11.7. And 11.7 deals with the binomial theorem. And instead of using some of the formulas from probability, permutations, combinations, and ways of counting up terms when we distribute, I'm going to use Pascal's triangle. And some of you may be familiar with Pascal's triangle from high school or something. But Pascal's triangle looks like this. It has a 1 at the top, then the next row has 1 and a 1. Then you have 1, 2, 1, then 1, 3, 3, 1. And we'll continue, but before we do, I'm going to show you where the numbers come from. So if we draw a triangle, let's see, let's do this one. This number is the sum of the two numbers above it. The left and the right edges are all ones. And if we draw a triangle with two elements in the top row and the one element below it, the bottom number is the sum of the two numbers above it. So if we add those two together, we get this. So the next row, we have a 1 here. 1 plus 3 is 4, so we'd put a 4 in between them. 3 plus 3 is 6. 3 plus 1 is 4, and then we have a 1 here. For the next row, we start with a 1, and then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then we have a 1. Let's do one more. We have a 1. 1 plus 5 is 6. 15. 20, 15, 6, and 1. So I'm not going to ask you to know tons of details about why those are the numbers that we use, how those numbers derived, other than you get them from adding the two numbers above it, and that's where this number comes from. And there are other ways of adding and getting the numbers, but that's the simplest way to do it. So when we're doing the binomial theorem, we're looking at taking a binomial, so something plus or minus something, to a power and multiplying it out. Now, we've squared things before, and we've even looked at shortcut to squaring things. We've cubed things before just by multiplying a binomial times itself 3 times. But we didn't really multiply much past that, because the more factors we have, that just gets really monotonous doing all that distributing. So the binomial theorem allows us to kind of take a shortcut to multiplying any binomial out. Now this only applies to binomials if we have two terms in here. So these values in Pascal's triangle are the coefficients for different powers of a binomial. The first row is for the 0th power. If you think about, if I take any binomial and raise it to the 0 power, anything to the 0 power is 1. So that's the coefficient if we raise something to the 0 power. The next row is if we raise something to the first power. If I take for example, y minus 5 to the first, the answer to that is y minus 5. You say, well, where does a 1 and a 1 come in? We have one of those, and we have one of those. 1y and 1 minus 5. But if we square something, let's suppose we squared y minus 5. That would be y minus 5 times y minus 5. We would have y times y, which is y squared. Y times minus 5, minus 5 times y, minus 5 times minus 5. So some of this discussion is not going to completely make sense yet. We'll put more meat on the bones as we go, but our coefficients here are 1, 2, 1. What that means is we have one of those, we have 2 of those, and we have 1 of those. Now you might say, we have 125, well, we had 5 to begin with. So if you look at y minus 5, we have a y to the second in the first term, and then we have a y to the first in the next term, and then we have no y's in the last term. With our minus 5s, we have a minus 5 to the second here. Minus 5 times minus 5, so this term has a negative 5 squared. The middle term has a negative 5 times 1. So I'm sorry, negative 5 times y, so we have a y, and we have 1 negative 5. And the first term out here doesn't have any negative 5s. So no negative 5s. So we have y to the second, y to the first, no y's. We have negative 5 to the second, negative 5 to the first, and then no negative 5s. So those are where our various values come from, the y squared, the negative 5y's, and the 25. And then these numbers down here tell us how much of each of those we have. We have 1 y squared. We have one of these first ones, which is y squared times 1. We have a minus 5 times y, 2 times, so minus 5y times 2 is minus 10y. And then the last term has no y's and minus 5 squared, which is 25. We have that 1 time, so we have 125. So that's what we get when we multiply that out. Now, for a square, it would be much simpler just to distribute it out. But when we have higher and higher degrees, that would get messier and messier and messier. So what I'm going to do is I'm going to copy the triangle. Let's go to the next page, and let's use the triangle to evaluate 1 or 2 problems at least. So let's do x plus 2 to the 4th power. So when we do x plus 2 to the 4th power, we're going to have an x to the 4th. We're going to have a term that has an x cubed, an x squared, an x, and then we're going to have a term that doesn't have any x's. We're going to have a 2 to the 4th, a 2 to the 3rd, a 2 to the 2nd, a 2 to the 1st, and then a term that doesn't have any 2's. So if we were to distribute that out, these are the different terms that we would get. But we wouldn't get just one of each of those. The coefficients in this triangle are going to tell us how many of each of these terms are we going to end up with. So remember, this is 0, this is to the 1st power, the 2nd power, the 3rd power. This is the row for raising something to the 4th power. So we're going to have 1 of these, 4 of these, 6 of these, 4 of these, and 1 of those. So we're going to have 1x to the 4th. We're going to have 4 2x cubes. We're going to have 6 2 squared, so 4 x squareds. We're going to have 4 2 cubes, so 8 x's. And we're going to have 1 2 to the 4th. So x to the 4th plus 4 times 2, so 8x cubed, plus 24x squared, plus 48x plus 16. So it's a combination of both ideas, the triangle, and then as we go farther into our polynomial, our order of the first term is going to decrease. So we start with x to the 4th power, and we go in descending order for the first term. And if we start on the right, we go in descending order right to left. We start with 2 to the 4th, 3rd, 2nd, and so forth. Or you could say for the second term we start with none and then we go up. So let's do another example. Let's copy our triangle over. And let's do 2x minus 3y. And let's do it to the third. So the third, this is the 0, 1, 2. This is the row we're going to use. So let's see what combinations or what different terms are we going to get when we distribute it. So we're going to get the first term cubed, the first term squared, the first term to the first, and then a term where we don't have the first one. Then we're going to get the second term. Oops, be careful. Let's start on the right. We're going to get the second term let's see, make that box go away. We're going to have the second term 3 times down here, twice here, once here, and none here. So 3, 2, 1, 0 for the 2 x's, 3, 2, 1, 0 for the 3 y's. And then this tells us how many of each of those different terms will we have. We'll have 1 of those, 3 of those, 3 of those, and 1 of those. So that first term is 2 cubed, so 8x cubed. This term is 2 squared, 4x squared times negative 3y. So that makes negative 12x squared y. This term is 2x times negative 3 squared y squared. So that'd be 18xy squared. And the last term is negative 3 cubed, which is negative 27y cubed. So when we were to multiply it out, distribute it, we would have 1 8x to the third term. We would have negative 12x squared y 3 different times. We would have 18xy squared 3 different times. And we would have negative 27y cubed 1 time. So if we simplify that, that's 1 8x cubed. That's 3 negative 12x squared y's. That's 3 18xy squareds. And that's 1 negative 27y cubed. So that'd be 8x cubed. 3 times negative 12 is negative 36x squared y. 3 times 18 is 54xy squared, and minus 27y cubed. So that's all we do. So the first term, descending order. The last term, descending order from right to left. And then Pascal's triangle tells us how many of each of those terms do we get. So we need to simplify once we list how many factors from each of the 2 terms we get up here. Simplify those and then multiply the first one by 1, the second one by 3, and by 1. Simplify that, and then that's what you get.